All right, today we're going to continue on with our systems of equations, but we're going to go ahead and move on from substitution from yesterday to elimination today. Again, I have this screen up here once again to remind you that we do have three different possibilities: the one solution, infinite many, or no solution. Well, let's talk about what we're going to be doing today. Our main idea is we're going to solve systems of equations algebraically using elimination. We're going to make sure both equations are in standard form. That's the ax plus by equals c form. Not for substitution, you have to get it into a y equals or an x equals. These you want to leave in standard form. Then we're going to pick one variable to eliminate. And then for number 3, we're going to multiply one or both equations in order to achieve opposite coefficients in front of the chosen variable. Kind of similar to getting common denominators. I'll show you as we get in. This is the main crux of the difficulty of this section. Is this step 3 is making sure that we multiply to get opposites. Then we're going to add down with elimination, solve for the remaining variable, and then we have to substitute back in to get the other variable. Remember, it's an ordered pair, so there's an x and a y. So if we solve for x, we still need to go back and get y. All right. So here's our first problem. We have negative 3x plus 4y equals 12 and 3x minus 6y equals 18. And notice, look at how they are set up. They are set up in standard form with x and y on one side and the number on the other. Now what we want to do is we want to pick one of the variables. In this instance, I'm going to pick x because x is already opposites. So we want opposites to happen, negative 3 and 3, or negative 4 and 4. Now these y's are not opposite, so we would have to do something different for the y's. But because the x's are already opposite, we can just kind of skip our step 3 here, that difficult one that I told you about. So we're going to eliminate the x's, and we're going to skip this step and go down to step 4. So we're going to just add straight down. And when we add straight down, negative 3x plus positive 3x is going to eliminate. That's the whole point of this elimination process. So when we add this straight down, we just kind of make a bar and a plus sign here and add straight down. 4 and negative 6 is negative 2y, and 12 and 18 is 30. And notice we eliminated the x's, and now we have an equation that just has y's. Divide it, and y equals negative 15. Now again, that's part of my ordered pair. If I had an ordered pair here, negative 15 is on one side, I still need to find that x. So how do I go back and find the x? I have to go ahead and to one of these original equations and put the value that I have, negative 15, in for y. It doesn't matter which one. They'll both give me the exact same answer because it's that one point that they intersect. They should give me the same answer. So we're going to put negative 15 into either equation. So here's just one equation, put negative 15 in. So we have negative 3x minus 60 equals 12, and then it's just a solving this. So plus 60 to both sides, negative 3x equals 72, divide it, and we get negative 24. Negative 24, comma negative 15. So again, could we have graphed this? Absolutely, but this is the intersection point. That's not easy to go ahead and graph. So we want to make sure that we can go ahead and do this algebraically so we can find those points if we need to. Let's try another one. All right, solve using elimination. Now we can eliminate the x's or we can eliminate the y's. Now with the x's, they're pretty close. This is 4x and this is 4x. But if I add them down, I'm going to get 8x. They're not going to eliminate. Remember, I have to have them to be opposite. So how do I make sure that they're opposite? Well, what I'm going to go ahead and do is I'm going to multiply by negative 1 down here. So it's going to be 4x times negative x. And this negative 1 gets multiplied by the 3. So this is going to be positive 3. So that's going to give me 5y. And it's going to be negative 18 here. So 5y and positive 10, because negative 28 minus 18 is 10. Okay, so we can put that negative through and that would work. And notice what we did is we just did it to one equation. Sometimes we can get away with just doing it to one equation. Sometimes we have to do multiple things to different equations. We'll get into the harder ones in a little bit here. But this is just a simple thing that we had to do. Just multiply by negative 1. So negative 4x, positive 3y, and negative 18. Well, and then we add them and we get 5y. Y equals 2. Again, plug it back in here. up at the top. This time they chose the second one, which is fine. 4x plus 3 times 2, or 4x minus 6. Add 6 to both sides, gives us 24. So x equals 6. So we can write our equation 6 comma 2, again, x comma y. All right, now we're looking at this one. Which one do we want to eliminate, x or y? It really doesn't matter. Since I have a singleton y here, it's probably usually easier to deal with the y, but we could deal with the x's. So I need to be opposite. So this is 2y, and this is 1y. So to multiply the top, I would have to multiply by negative 2 to get a negative 2 in front of this y. So I'm going to take this first equation, and I'm going to multiply every bit of it by negative 2. So I get negative 4x, negative 2y, and negative 46. And what that does is then creates this situation where the y's are opposite. And that's what I want to do. That's how I have to get it to eliminate. So I'm kind of looking for like a common denominator. What would be the common denominator between 1 and 2? Well, it's 2. So one's got to be positive 2, and one's got to be negative 2. So I could have multiplied the top by 2 and the bottom by negative 1 if I wanted to. Any kind of combination that's going to give us opposites is what we want. If we're looking at the x here, 2 and 3, I would want them both to be 6's. So I'd multiply the top one by 3 and the bottom one by 2. One of them have to be negative, and we would do that problem. So here, let's go back to the one that we're actually working on, though. Here's the negative 2. So we multiply by negative 2, and notice the y's are opposite. So now I can add down, and I get negative x equaling negative 9. Well, then divide by negative 1, and x equals 9. Again, we're going to plug it back in here. Either equation, I'm just going to take that first one. 2 times 9 is 18. 18 plus y equals 23. Subtract it, and y equals 5. So we have 9 comma 5. All right, one more here. This one's obviously a little bit of a more complicated one because there's nothing that's really easy here. We have to just choose one to get rid of. If we were getting rid of the x's, we would get them to 12. If we're getting rid of the y's, what does 3 and 5 both go into? 15. Now, the reason why I'm choosing the y's is because it's already got a negative. I don't have to do much with that one. So I got to multiply the top one in order to make this 15. I got to multiply this top one by 5 and this one by 3. So method 1 would be to eliminate the x's, and they're going to show you both methods here, both ones, just so that you can see that they're going to be the same. So if we're going to eliminate the x's, that's got to go to 12. So what do I got to multiply the top one by? I got to multiply by 3. What do I multiply the bottom one by? 4 to get to 12. Again, probably one of them I'll need to be negative. So on the bottom here, I multiply by negative 4 to get negative 12, but it does work. When I do that, 29 equals 116, divide, y equals 4, substitute in, and you can follow the math here, and we get x equals negative 1. Okay. So let's try it the other way, eliminating the y, which is what we kind of talked about first. It's already got a negative and a positive, so I didn't have to worry about anything special. So multiply the top one by 5 and the bottom one by 3. 4 times 5 is 20, 15, and 40, and then so on. So 29x equals negative 29, and x equals negative 1. So then I'm going to take the negative 1 and plug it back in. Gives us negative 4 plus 3y, add 4. 3y equals 12, y equals 4. So obviously, if you notice, it matches the same answer as we had for the other way. So it doesn't matter which variable you use, negative 1, whether you get rid of the x's or the y's, you still got negative 1 comma 4. Now, this is all great, except for, if you remember, we have 3 possible types of answers. We can have an intersection point, like all the problems we just did, or we also can have the no solution or infinite solution. So we have to be aware of those also. So let's take a look at this one. 8x plus 2y equals 1, and 2x plus 3y equals 6. So what do 8 and 2 go into? They both go into 8. It's, like I said, it's kind of doing a common denominator here. So The top one I don't have to do anything with, so you could say I multiply by 1. See, I just rewrote it exactly how it is. The bottom, to get it to be opposite -8, I have to multiply by -4. And notice what happens here. We get -8 minus 12y, and both x's and y's both cancel out, leaving me nothing. Over here we get -23. Last time I checked, 0 it does not equal -23. This is a no solution. These two lines, if I graph them, would be parallel. Remember from substitution, when we got something that wasn't correct at the end, when everything canceled out, that's a no solution. So how do I get all solutions? Well, everything should cancel out. It should be 0 equals 0. That would be an infinite many solutions. If this side cancels out also, it would be 0 equals 0. All right, and that's what I have for you today.